Hi, today we're going to talk about average rate of change and instant rate of change and how they're different and how they're similar. So first we're going to develop a notation for average rate of change using the difference quotient. And the difference quotient we worked on earlier, so hopefully you'll remember that, but if not, we'll get it back real quick. So what we're going to do is take this picture here. We're going to look at trying to find the slope between these 2 points, one point here, and I'll label that point, that's the point x, f of x, and the slope between that and this second point here, which is the point x plus h, and then the f of x plus h is its y value. So we're looking to find the slope between these 2 points. So if we do that, just use our normal slope formula, y minus y over x minus x. Here's what we're going to end up with. So if we take our y value, f of x plus h, minus our other y value, f of x, over the x value, x plus h, minus the other x value, x, then we'll get the slope, or the average rate of change. Now there's only a little bit of cleaning up I can do here. On the bottom, this x and this x will cancel. So what I'll end up with here is that the average rate of change, or the slope, is equal to f of x plus h minus f of x divided by h, which is the difference quotient. Now, just to make sure you understand, the h is a value that represents a distance between your starting point here and your second point. So when we use this formula, h is the distance between the point that you are starting with for your slope and the second point. And then the y values are f of x and f of x plus h. So this little difference quotient will find us the average rate of change from x to a point x plus h. Okay, so now we're going to use that. So we have this formula that's going to give us our average rate of change, or the slope of the secant line, as you can see in our picture. So we're going to try it by using that to find the average rate of change for the function x squared from the point 2 to 5. So if we're finding the slope from the point 2 to 5, notice that the difference between 2 and 5 is 3. So this will be our h. Okay, so average rate of change is going to be f of x plus h minus our f of x divided by h. So let me fill in. So our x is 2 and our h is 3. So we're going to have f of 2 plus 3 minus f of 2 over our h value, which is 3. So carrying that down, we're going to find f of 5 minus f of 2 and divide that by 3. So what is f of 5? Well, remember the function is x squared. So if we want to find f of 5, you're just going to plug 5 in for the x and square it. And f of 2 would be plugging 2 in for the x. So 2 squared over 3. So we end up with 25 minus 4 over 3, and 21 divided by 3, which is 7. So our average rate of change, or our slope, from x is 2 to x is 5 on the function x squared is 7. And you could verify that graphically. You could take a look at the graph of x squared and you would see that from the point 2 to 5 you have a very steep line, and the slope of that line is 7. Okay, let's try it again, but a little different. We're going to have a more complicated function. We're going to take x squared minus 2x, and we're going to find the average rate of change from the point x is 4 to a point h units away. Now they're not going to tell us what h is. So for h, we don't plug a number in, we actually just used h. So starting with our formula, f of x plus h minus f of x over h. So what's going to happen here is we're not going to get a number for an answer, we're going to get an expression. So starting with plugging in 4, so we're going to have f of 4 plus h minus f of 4 over h. Okay, so how do I find f of 4 plus h? Well, I plug 4 plus h into our function up here. So doing that, 4 plus h in there for x squared, so that's going to be 4 plus h squared minus plugging 4 plus h here, 4 plus h. Alright, so that's our f of 4 plus h minus, now f of 4 is plugging 4 into the function. So that's going to be 4 squared minus 2 times 4, which is 8. Okay, all that over h. Okay, so we've got some algebra to do here. So we need to FOIL 4 plus h squared. So if we FOIL that, we're going to get 16 plus 8h plus h squared. So if you write that out, do FOIL. Distribute -2, so we get minus 8 minus 2h. And then let's clean up this 4 squared minus 8. So that's 16 minus 8, which is just 8, all divided by h. Okay, so again, we have some things that are going to cancel out here and combine. So we have a 16, when you subtract 8 and subtract 8 more, gives you nothing. Combining our like terms, let's see, we have a 8h minus 2h, so a 6h. So we have h squared minus 6h, all divided by h. Now, we can simplify this if we factor on the top. If we factor out an h, then we can get something of this form, and now that we have a common factor, the h's can cancel. So here's our expression for the average rate of change. It's just h minus 6. So to use that, all you would need to know is what's the value of h, and then I could find the slope between x is 4 and any point that's h units away just by plugging in this simplified little formula here. So that's a quick way of summarizing how to use the difference quotient to find your average rate of change. Now where we're going to go to next is we're going to use this same idea and apply it to the instant rate of change, or what's called the derivative, and that's really what we want to get to next. So that will be in our next video. Thank you. Hope this was helpful.